So shall we begin?
I'm sorry?
Shall we start?
Yeah, we should start. It's now the top of the hour, and welcome to V6OPS. So Ron is displaying the note well, and so if this is new to you, please note well. We have a note taker, that's Shuping, and thank you, Shuping, for taking notes for us. We don't have a Jabber scribe, and I note that there's at least one person who's following us by Jabber. So if somebody would please open Jabber and act as a Jabber scribe, I'd appreciate that. We have at least two on Jabber. Okay, so now moving ahead, Ron, you want to show the agenda? Our agenda.
Yes, I know. Getting there. There we go.
Okay, there we go. Okay, so we have a relatively short agenda this time compared to some that we've had. The IETF 109 meeting was pretty well jammed, which was unfortunate. But so Ron and I have a few comments on chatter regarding IPv6 in the IETF. And then we have 4 talks. The first one relates to a hop-by-hop options header, which is being discussed in 6-man. The question there is basically whether V6OPS has any input to 6-man that might be useful. We have a talk on deployment status, a talk basically imported from TCPM. They would like to talk about something that Linux is doing with the TCPM flow labels, or the flow label, IPv6 flow labels in a Linux environment. And then Fernando is going to talk about the addressing considerations document that he's got up and which has been under discussion. So Ron, could we look at the chair's comments slides? Here we go. Okay. So Ron and I were talking over the weekend and had a few thoughts on the chatter about IPv6 that we hear in the IETF, and which is frankly kind of disturbing, especially in the context of deployment in the Great Wide World, the world outside of Europe and North America. When we had a talk at IETF 109 from Reliance Gile, or from a gentleman from Reliance Gile, and he came back to Ron and I after the thing was over and said, could we please just take all of the Class E space and make it available as IPv4 because I need it. That has been discussed before, and actually there is a current discussion of that going on Nanog for those of you that are on the Nanog list. Okay, so Ron, add a slide, please. Okay, if we look at IPv6 demand, there's a lot of demand, and we're essentially out of addresses. And we see proposals like the one that's being discussed on Nanog right now, and also frequent proposals to take space that was allocated to US military or other people in the distant past and which is not advertised on the internet. And could we please use that as private space or reallocate it to somebody? And the problem with both of those ideas is, and we've had this discussion before, and let me just repeat it, that it's a Band-Aid. It solves the current problem in the sense of extending the life of IPv4 for a week, a month, basically until it gets used up, but it doesn't really address exhaustion. Next slide, please. Okay, now if I look at IPv6 traffic, and in this I'm using a tool that was put up by Eric Bink, and in this particular case uses Google data. He can also get the APNIC and Akamai data, and there's other people that put data about internet accesses on the web. I made this slide yesterday, so this is as of yesterday. Google indicates that 77 countries are using native IPv6 for greater than 5% of their accesses to Google services. Now, obviously, that means that there are some that are kind of just getting started. There are a few that Google actually sees more IPv6 than it sees IPv4. And the vast number in between. In doing this, there's, I don't know, an interesting difference between sources. Google and Akamai, if you ask them what they see, they're talking primarily about accesses to their CDNs. If you ask APNIC, you're talking about traffic that actually went over the internet backbone. So when somebody uses IPv4 or IPv6 to communicate, what that means is that both they and the entire path of equipment in between the two endpoints are running IPv6. This tells me that we have actually pretty wide deployment. Next slide, please. Now, this is a slide that I pulled out of a deck that I built 2 years ago, so the numbers are a little bit out of date. But a Central American country wanted to build a greenfield network, basically as an NREN. And they had a proposal, they had multiple proposals to build it using IPv4, and they had at least one proposal to build it as an IPv6 network. And in looking at the cost of doing those, quite apart from equipment and software and actual services of running wires around or fiber or whatever would be involved, looking just at the cost of the addresses, building that network using IPv4 would cost them multiple tens of millions of dollars. Building it out of IPv6 cost $2,100 annually as of 2 years ago. It may have changed since then. And point being that whenever I'm talking with somebody about IPv6, they say, "What's the business case?" And to me, this looks amazingly like a business case. It costs less money. You can save an awful lot of money by running IPv6. Next slide. In the IETF, the chatter isn't about using IPv6 in networks. The chatter primarily seems to be about using it as an underlay technology, a drop-in replacement for MPLS. We don't hear too much in the IPv6 about using, in the IETF, about using IPv6 as an overlay technology, as communication between endpoints. It's mentioned in internet drafts and in some cases under duress, but the big chatter seems to be about source routing, SRv6. So next slide. So Ron and I have a question, kind of about IETF discussions and the chatter. IPv6 in the overlay was instituted in the early 1990s to address shortage. The fact that there aren't enough addresses around in IPv4 to do the job. Now we see IPv6 in the overlay in ISP, residential, and other networks, and we see its utility in some applications like web browsers and such. We don't usually see it in enterprise networks, and it isn't universally in applications. And it's not obvious how IPv6 in the underlay addresses the problem of address space scarcity for developing countries, for people that are looking for address space. And so the question that Ron and I found ourselves asking ourselves is, are we collectively doing something wrong? Now, I'm not going to throw open the floor to discussion, primarily because I think a lot of this will come up about 2 talks from now, and we can discuss it on the web, or on the mailing list as well. But something I would like us to think about is, are we, the IETF, doing something wrong in our discussion of IPv6 and IPv6 deployment? So Ron, let's move to the first talk.
Okay, back to meeting materials. Sorry for the slowness here.
I mean, what if you go to PT and then, well, I guess the insurance companies would say the PT people would never say no.
Whoops, not what I wanted.
And go down the bottom. There you go.
It should be right here, no? Oh, I see it, right here. There it is.
Okay, and Gyan Mishra, I believe you were going to present on this.
Yes. Yeah, hi. So this is Gyan Mishra with Verizon. So I will be presenting processing of hop-by-hop options header. Next slide. All right, thank you. So the motivations. So the HBH options header is a valuable container for facilitating new services. So the hop-by-hop processing behavior is very desirable. It's something that's, that I think overall, I think in the industry, and we're seeing a lot more, I think, new features such as segment routing and others that are now starting to, or other, I guess, flavors, I guess OM and others, Altmark, PM2D, that are wanting to look at using and taking advantage of the extension header capabilities with and utilizing HBH options, and then the power behind that with IPv6. So with that, so the one big issue, I guess, and that's really been industry-wide, I guess, related to HBH is the HBH options header has been rarely utilized in current operator networks, and the problem is operators have been really reluctant to actually allow HBH into the network, and just with that separation of control plane and data plane, and having traffic that should be processed in the forwarding path having to be punted to the control plane, and that impact of traffic, being forwarded and having to get rate limited or pushed down to the control plane, possibly impacting the management plane. So that has been a worry for operators, just historically, and it just has been an overall really historical problem that's existed, that's really prevented HBH options and even destination, header options from really getting off the ground just due to that possible impact. So the main purpose here is breaking the endless cycle that's resulted in the HBH, really becoming a DOS vector. So that scenario where you have an HBH header, valid, options, that are packaged with valid HBH options, but now because the HBH is a DOS vector, most operators being reluctant and afraid of that cross communication from, something that should be in the forwarding plane now being punted to the control plane and impacting the management plane. So that's just been a really historical issue, and now being able to develop and being able to use the HBH header, it's really impacted that development. So now what the goal is, enabling the HBH options header to be utilized in a safe and secure way without impacting the management plane. Ease of deployment of new HBH-based network services in multi-vendor operator network scenarios that can now be deployed without operational impact. Next slide. So our modern router architecture. So with our modern router architectures, so they maintain a strict separation of control, the control plane and the forwarding engine. The control plane relies on software, historically general purpose processors vulnerable to DDoS attacks. The forwarding plane relies on hardware, flexible, high performance software programmable MPUs, capable of handling very high packet rates and performing complex tasks such as HBH processing. The interface between the control plane and forwarding plane, generally there's a rate limiting mechanism that allows the implementer to protect the control plane against DDoS attacks. However, with that, the downside, of course, causing consistent packet drops and impacting normal IP forwarding. Next slide. Common implementations. So the value of the next header field in the IPv6 header. So the trigger for the default processing behavior of the HBH. So common implementation. So once the device receives an IPv6 packet with this next header field set to 0, they'll be directed to the slow path. So the option type. The option type of each option will be examined before the packet is sent to the slow path. So in most cases, such processing behavior is a default configuration and can't be changed. So that's really been the general. As soon as that HBH header is received with that type 0, it's generally, and this has just been a common behavior across most ASICs, fixed function ASICs, where as soon as that packet's received, got that HBH option 0, it's forwarded to the slow path. Historical reasons with that, HBH options were not yet really well understood by operators as well, and throughout the industry. And flexible fixed function ASICs performing proprietary functions were not so capable as they are today with modern software programmable MPUs that can forward at line rate in the fast path and still be able to perform complex tasks such as HBH forwarding, options processing without having to punch the slow path. Consequences: all packets containing HBH are dispatched to the slow path, and then you got the result of DOS attack on the control plane, congestion of the slow path, impacting critical functions, rate limiting, and impacting the overall management plane. Next slide. Next slide. Thanks. So the desired processing behavior. So with the control plane, should be protected, against undesirable traffic. So with the HBH options that are not supported to be processed by the control plane should not be sent to the control plane. potentially causing the DOS attack. So just kind of, I guess, based on that, I guess when you think about it, you have, when you look at the HBH options, there's options that are destined for the control plane, and then there's options that are destined for the forwarding plane. So the idea is behind this problem statement, and then also a possible solution is decoupling options that are bound for the control plane to remain processed by the control plane, but options that are not destined for the forward plane and really should stay in the forwarding plane, but should not be processed by the control plane, should be segregated and actually treated differently. So the HBH options header should not be directed sent to the control plane once a packet is received, since these options may not be aimed for the control plane. So that's really the kind of big concept and idea, is really that separation, decoupling options that are HBH options that are control plane destined versus HBH options that are really destined for the forwarding plane that could be processed in the forwarding plane. Source nodes should not enable HBH options that exceed the maximum length of HBH options headers to 2048 bytes, encoding the number of HBH options that exceed the lowest processing capability of nodes along the path, encode the number of HBH options that exceed the maximum overall length of the extended header chain. So the idea is basically better to separate the two option types that are supposed to be processed by the control plane and forwarding plane respectively, so breaking them into two buckets. Desired processing behavior for the two types options are different, and the options are really aimed for the control plane are better to be consumed, to not consume forwarding plane resources. And that's really the big deal, that why have them be processed by the forwarding plane? Let them really be processed by the control plane, and only have anything destined for the forwarding plane be processed at line rate by the forwarding plane. So new development should be compatible with existing deployments. So that's something that we want to be cognizant of any solution that we propose. Since the default configuration of some devices cannot be reconfigured, the update of the entire network cannot be done within a day. So it would take, with any solution, it will take time to progress and actually be able to. It is definitely like it is a paradigm change. So it will take time, even with any proposal, to move from what we have today to a new solution. Next slide. So migration strategy. So in order to achieve the desired processing behavior of HBH options headers and facilitate the ever-emerging new services to be deployed in operator networks across multiple vendor devices, the migration can happen in three parts as described. So first, the source of the HBH options header encapsulation, the information carried in the HBH options need to be first categorized and encapsulated into either control options or forwarding options, and then encapsulated into different packets. That's the first step. The second is the nodes within the network. So the nodes within the network updated to the proposed behavior, introducing the previous section. So that's separation of the processing behavior of HBH options that are destined for the forwarding plane. The edge nodes on the network in this third step. The edge node should check whether the packet contains an HBH header with control or forwarding option. Packets with the control options may still be filtered and dropped, while the packets in the forwarding option should be allowed by the ACL. It is certain that there is no harm that can be introduced by the HBH options to the nodes and services that can also be allowed. During the migration stage, the nodes that are not yet updated will stay with their existing configuration. So the overall idea is really separating into two buckets. Anything that's using the existing HBH option would be the control plane options, and then anything that's any options that are destined for the forwarding plane. The idea is they would use a new HBH extension header that would be proposed. Next slide. Next slide, sorry. So we would like to ask for workgroup adoption. We've proposed this on the last IETF by Shiping, and we would want to get feedback and comment from the work group, and based on this concept and ideas and thoughts on work group adoption.
Excuse me, Fred,
So-
could you put me in the queue?
Sure. So, okay, so we're going to Q&A now. Ron, you asked to be in the queue. You're in it.
Okay, Guion, thank you for this work. It's parts of it I think are very important, but we probably need to do a little dissection on it because of working group charters.
Understood.
There is part, there is part of this work that falls within V6OPS charter. That is that we have a hop by hop option. We would really like to use it and we can't for the following reasons. There are parts of this work that I think fall outside of our charter. The proposal to divide options into two classes, control plane and forwarding plane. And I think you talked about a proposal to create a new extension header type. That also
Right.
falls outside of our charter. So that would, that's something, Bob Hinden might want to comment on. I think he's in the room.
Understood. We do have a draft that's in the HVH forwarding, which is a 6-man. I think there's a further slide, I guess, the next slide down, that has the proposal, which is in 6-man. So this draft is actually really, it's just for the problem statement, and then the concept, and then the solution is the solutions draft is in the that's with 6-man.
Yeah, it would have to
But,
be problem statement, totally devoid of solutions.
Understood. So this problem statement it is devoid of solution. It's just completely problem statement. Yes.
Okay, Bob, you're in the queue.
Hi. Yeah, I mean, I've read the draft, and first I'll disagree. It talks about two different types of options, and that is a solution, not a problem. I'm very supportive of the problem statement part of this. I agree that it would be much better if hop-by-hop options worked and were useful. I've proposed one for path MTU discovery. There could be others. And I actually have a draft that will be discussed in 6-man on Thursday. That's a different approach than what this is alluding to. I think that we need to make hop-by-hop processing simpler and sort of reduce, and basically they should only be processed in the fast path, or I forget what, yeah, I use slightly different terminology. And I personally think that creating, well, first of all, IPv6 since forever is very clear there's only one set of hop-by-hop options, not two. So that's a fairly big change. But I think the notion of creating another option container with hop-by-hop is going to just make things more complicated and will not solve this problem. I think it's going in the wrong direction. The draft I will talk about tries to make it simpler, with the same goal of making hop-by-hop options usable in the operational internet. So I'm very, very much supportive of V6OPS doing a problem statement draft, but as Fred said, it needs to be devoid of pointing to particular solutions. That's owned by 6-man.
Understood. Thanks, Bob.
You're welcome.
Okay, Shuping, you're in the queue. Shuping. Okay, Jen, do you have something you want to say?
Yeah, hi. I have a potentially very stupid question. So I assume for some reason that this separation between something processed in slow path and something processed in fast path is not a property of a packet. I would assume it's a property of the router, what kind of things it could process in the slow path and what kind of would process in the fast path, right? And this could change over time. So how can this draft how would this draft deal with that? What happens if in like 2 years time we would be able to process in hardware things which we cannot process now?
Yeah, that's a good point. I mean, I think with that it would be a evolving that let's say let's say new options come up that are that should be processed in the slow path. They would remain that are control plane options. They would remain in the slow path, but new options that do and it is, I guess it would be an ever evolving change that as new ones come up, because it's two separate buckets. So that is something that we would have to consider. I mean, that's a good point. A consideration having two buckets, that it's not going to all sit in one bucket as processed by the normal processing, where it's processed by this forwarding plane and then forwarded to the control plane, where now you would have some that are actually in the forwarding plane and some processed by the control plane. I think the one way to look at it though is that if you have with these two buckets, if you have options that are, let's say, existing options and anything new, they would stay status quo, that there would be no change. But what would actually change is anything new that comes about that actually requires line rate processing and processing in the fast path. And that's really the idea, that keep status quo anything that requires control plane, and that would be like legacy. Anything that exists today that's control plane, and anything that new that comes up would stay as is. It wouldn't change. It would be processed by the existing HBH header. But anything new that comes up that requires the enhanced forwarding capability to be processed at line rate in the fast path, that would end up be decoupled and use the new options header.
Let me make a suggestion that I think would clarify this particular discussion, and that is, please ditch the words fast path and slow path, because that's not the question. The question is forwarding plane versus control plane. And if you make that clear, then this discussion becomes an awful lot simpler.
Okay. Yeah, no, that's I appreciate that. That's helps with the discussion. So control versus forwarding plane. Thank you.
Yeah.
As far as with this draft and workgroup adoption, what are your thoughts as far as the problem statement? As you had stated, I think this draft really, it should be devoid of the solution. So maybe just really for this, I think discussion really focusing really just on the problem statement really makes sense. As this draft and V6 ops is really the problem, and understanding the problem and consensus that this is the problem that we want to address and move to be able to adopt this as with the work by the work group.
Well, yeah. So looking at the charter, as Ron points out, the charter allows us to develop problem statements and send them off to other working groups, 6-man being an example, and allows us to comment on things, give an operational viewpoint on things that are discussed in other working groups. And so this draft, from a problem statement perspective, does that, and that's good. What I would suggest is that the draft be reworked a bit and literally be a problem statement, and then we can discuss on the list whether it should be adopted. But with the current solution stuff that's in there, I don't think we can't adopt it.
Understood.
I would agree that we do have a real problem. We have so many proposals in which we need a few more bits in the IPv6 header. The right way to do that is to use the hop-by-hop extension. But because hop-by-hop extension isn't a viable option, we're finding, ways to shoehorn it in the flow label or shoehorn it, someplace else. So we do have a real problem. We really need HBH back. Well, this is, and by the way, I'm speaking as an individual contributor. Now, speaking as a chair, to keep this draft within the scope of V6 ops, we need to make sure that what we produce is a problem statement, totally devoid of solution. So it does need a little bit of scrubbing.
Yeah, understood. So so we can do that. Update the draft and really make it completely devoid of a solution, and then take it to the mailing list to review. And I think that's really the focus. So, and as far as the solutions, as you had said, Ron and Fred, we can take that. That's really on 6-man. But that's really, it's completely separate from really this. Right now, really the main focus is the problem statement, which is, it is definitely a real problem, and being able to really leverage the HBH option, which I think operators, and there's so many use cases that could really take advantage of this. So it's definitely a problem that needs to be solved. So appreciate the feedback.
Okay, thank you. Now, Shuping, you were in the queue and I called on you, and for some reason we couldn't hear you.
Hello, can you hear me now?
I can hear you now, yeah. So
okay, good.
Whatever it
Thank
was you wanted to say, go for it.
Yeah, I think what I wanted to say is I'll talk about, and I just want to confirm that we share the same goal as Bob said. We want to make the hop-by-hop really usable for the operators, and because a lot of new features really depend on it, for example, the path MTU. And currently we have two drafts, one in 6-man and the other in the V6 ops. The reason we have this draft in V6 ops is about we want to have this problem statement, and this is what we really want. And to at the end of the draft, actually we revise it before and to this version, and we would like to we removed the solution part, and we can do it further with the help of the working group. Actually, the main purpose for this draft is to state the problem, and also we had some requirements for how to precise the hop-by-hop would be reasonable. And here we would like to get the help and feedback from the working group. Thank you.
Thanks.
Okay, thank you. Warren, you've got your hand up. What do you have on your mind?
Thank you. Yeah, I'm not sure if the mic line was closed. If so, I will sit back down. If not, oh, speaking with no hats. To me, it seems that once all the sort of solution is removed from this, the only thing you end up with basically reduces down to, it sure would be nice if hop-by-hop options worked. And the reason that hop-by-hop options don't currently work isn't that vendors are inherently evil, although some might be. It's because it's hard to implement a lot of this in hardware, and you don't really know ahead of time what routers along the path might have done so. So there's also, it's really hard without knowing all of the vendor implementation details to be able to predict what will actually work correctly in the forwarding plane or fast path, whatever you want to call it. So I don't entirely understand how anything's going to work with this, other than saying, this new thing which I'm writing, I really, really, really want to work on the forwarding plane, and I certainly hope it does. I don't think when any of the current hop-by-hop options were created, the desire or plan was that they don't work properly because they get bumped to the control plane. So I don't really see how this is going to change anything, other than sort of hoping or wanting a pony.
Thanks, Warren, for your feedback. I think, with the problem statement, I think as Shipping mentioned, I think, and feedback from Ron and Fred, we'll focus on the problem statement and really the problem, which is definitely a issue, to be able to use the HPH option and make it really viable. I think to get from like point A to point B is not easy, and it is fairly complicated to get there. As there are the chip vendors and operators, and there are a number of variables involved to be able to make HPH options really viable. So it's not as simple as that. I think the solution is fairly complicated, as there are a lot of variables. But I think as far as the problem, I think it's something that's existed for a long time, and I think this is something that we want to really address and with this draft. And so it's made aware, within V6 Ops that we have that set in stone, that the work group and everyone agrees on the problem. Then it's really a matter of, as Bob has his draft with an idea with HPH, and that of how we can make it viable with a single HPH option, which is, I really it's great that Bob had come up with that idea, and then the idea that we have with the solutions draft, that's another. And I think any one of those ideas, that anything that can really make HPH viable, we're all for it, because it is something that really the operators within the industry really want to be able to leverage, and not having a path toward a solution. That is a problem. So we're open to any and all solutions that can solve the problem. But at this point, we're really focused, and we'll clean up the draft to get it razor focused on the problem. Thank you.
I think we lost Fred. Should I go ahead?
Oh,
Yeah, go ahead. I think I'm all set. I think if you want to move on to the next one.
No, I had another comment.
Oh, sorry. Sorry. All right, go ahead.
Yeah, go ahead, Bob.
Sorry.
Yeah, so I agree with a lot of things that Warren said. And, so I have two thoughts. We are going to have, if we get something that works, then we're going to have to be fairly careful about what we allow to be defined for new hop-by-hop options. I don't actually know how to do that. So that's going to be, because you could obviously, you may look at an existing one, and that's possible to do in the forwarding path. Yeah, I'll call it the fast path. But I could easily imagine defining new things that aren't, or at least not currently. The other thing, before Six-Man goes off and pushes something through the process, we're going to have, I think, a lot of feedback from vendors who build this stuff and operators who deploy it, that this is something that they're going to implement and then use, because otherwise it's fairly pointless. And so we should not, there's going to be, I think, a need for a lot of close coordination. We can't just write a spec, standardize it, throw it over the wall, and hope for the best. So there's going to need to be a lot of, I think, collaboration with, people who build the routers and the chips and so forth, and the operators who run the backbone networks, who would deploy this stuff. Thank you.
Okay, thank you,
Fred,
Bob.
Thank you, Bob.
Fred, may I jump in for a second?
Yeah, sure, go ahead.
Okay, one quick last comment, arguing with Warren a little bit. A couple years ago, I would have totally agreed with what you said, but I think things have changed. Two things. First, ASICs have become more capable, so it will be possible to process some, but not all of the hop-by-hop options we can think of. The other thing is we're seeing more and more requests to repurpose fields in the base IPv6 header. We need a few more bits here and there. And as that happens, sooner or later, we're going to have to break down and make HBH work.
Okay, thank you. Shupeng, you came back into the queue, and let me give you the last word before we go on to the deployment status discussion. Shupeng?
Clarify. And to Warren, the evil isn't the operator. The evil is about the implementation. But in the old times, when the hardware is not capable, just as Ron just comment. But the problem is when the hardware becomes capable, the implementation still stays there. It's not changed. Currently, there is no proper specifications to get the implementation. And that is the missing part. And I think the draft here, and we want to have this somehow is kind of a guide to fix that gap, to get the solution to be developed in the 6-man. Yeah, thank you.
Yeah, thanks, Shupeng.
Okay.
I just want to make one point before we end. So in the draft, I think one piece that we had put in there, and it was in the update, and it was just related to, I think as Shupeng pointed out, one of the big problem is the chip manufacturers. But I think the thing, because there's two categories, there's a fixed function ASICs, which are not as flexible, and then you have your NPUs that are software programmable that are much more capable. But because you have these two flavors, and manufacturers, and based on the cost and efficiency, and there's so many variables that go into building the chips, they choose to go with the fixed function ASICs versus NPUs. So it is an inherent industry thing, and it's really the chip manufacturers that is the problem, and they're making the decisions on what to use, not why, and their decisions on choosing to use NPU and a fixed function ASIC versus an NPU. I don't know how that problem would be solved, but that is definitely where the problem lies, as Shupeng mentioned. Thank you.
Okay, we do need to move on. Ron has the next talk under display. And now who's presenting this? Is this Paolo?
Hello everyone. So this is Paolo Volpato. I'm with Huawei Europe, and I'm presenting on behalf of the authors you see listed in the slide. Next slide, please. Okay, so basically for those who are not aware of our draft, let me just share some background information about what we have done. So I would say that the goal of this draft is twofold. So first is to provide an updated view of the deployment of IPv6, highlighting what it is still missing, to get to its full adoption. On the other hand, we'd like also to provide suggestions on how to improve the current IPv6 deployment strategies, and for that, trying to, let's say, partially answer to the question posed by Fred at the beginning of our session. We have inserted a part in the draft named Call for Action to stimulate further investigations on what are still considered the open points related to IPv6 adoption, and to suggest waves to move forward. Ideally, we would like to provide an updated view of the practices and the plans described in RFC 6036, that is probably more than 10 years old. Some incentives are also discussed in our draft, and thanks to the feedback we got from the mailing list, we have also started to consider, let's say, adding some text, some considerations on IPv4 exhaustion. So this is the current status. We can move to the next slide, please, where we show the differences from version 1. So we presented our draft before IETF 109. Since then, we have to thank the people that provided feedback, both in the mailing list, but also privately. And we added, as said, one specific section on IPv4 exhaustion. We introduced some considerations for the usage of IPv6 in cloud service providers, networks, and their data centers infrastructure. We have also updated the numbers on the status of IPv6, and we have further developed, let's say, the part called call for action. Next slide, please. Okay, so some updated numbers on IPv6. You find all the references in our draft, but let me mention EPNIC because we gather a lot of the pieces of information that we have reported here in our tables. So first, where do we stand with the adoption of IPv6? The number of estimated IPv6 users reached 1.2 billion at the end of the last year. And I would say worth noticing is the compound annual growth rate, which is slightly above 40% if we consider the period from end of 2016 to end of 2020. The IPv6 allocations also grew. So you see the different numbers related to the registries described in the second table. And again, it's interesting to note that despite the drop in the RIPE region, which is described in the penultimate row in the second table, the IPv6 allocations have grown quite a lot. And if we compare the two address families in the third table, IPv6 has grown more than IPv4. And this is also represented by the last table, where we see that the total number of autonomous systems capable of IPv6 has grown more than the total worldwide. I think we can move to the next slide. So one of the sections of our draft also discusses a short survey that we proposed to some 50 operators in Europe at the end of the last year. Again, all the details are described in the draft. We just mention here that the majority of the operators we asked to provide an answer to the survey declared we have plans to move, adopt, or let's say deal with IPv6. Some of them have already deployed IPv6. Some of them are in the process of moving to IPv6. This is represented by the first pie in the bottom left. In the middle, the other question we asked, which is the business segment where you see adoption of IPv6, and you can see that all of them are covered. We have both mobile, fixed, and enterprise, and they are quite equally split. The third pie is related to the technologies to be adopted in the mobile space. And you see that the favored technologies are mainly DualSec and XLAT. And the reason for moving to IPv6 in, I would say, almost all the answers is related to the lack of IPv4 addresses. And I would also add probably an increased attention to IPv4 depletion, which is a good sign, I would say. Next slide, please. Okay. We have also expanded in the latest version of the draft some considerations about the adoption of IPv6 in specific domains apart from network operators. So we have added some text related to the use of IPv6 in enterprises. What we can say is that in many cases, the decision whether to go with IPv6 or not is dependent on the service offered by the upstream provider. If the connectivity provider runs IPv6, then, well, I would say this is fair enough. If not, it's easy that enterprises still remain with IPv4. And in doing that, probably the risk is that they may miss some specific deadlines or opportunities in those markets or countries that have adopted, let's say, enforced policies in favor of IPv6. For cloud service providers, most of them have already adopted IPv6 in their data center facilities, or in some cases, their data centers are completely based on IPv6. Industrial internet, so we consider IoT, industry automation verticals. We see there are a lot of advantages when adopting IPv6 for the connectivity, mainly related to the wide address space, but also to the, let's say, characteristics, the basic characteristics of the protocol, mainly associated with the ability to self-configuration or automatic configuration. Next slide, please. So we have added a new part dedicated to the exhaustion of IPv4. The data comes from the registries and is also summarized in a very interesting article by Dr. Geoff Houston that is referenced in the slide. So let's start with the number of available IPv4 addresses. In that article, this is summarized, which is represented by the table on the bottom left. So looking at the table, we see that we have probably some 80 million of available IPv4 addresses, considering both the really available from the registries and the reserved addresses. So apparently, if we based our assumption on the numbers represented by the table, we are approaching the real exhaustion of the IPv4 address space. There is one point. So if you have the opportunity to look at the article by Dr. Houston, there is also another chart, which is represented on the right, which details the number of unadvertised addresses. So looking at the numbers, we have probably around 50/8 or 50 class A available, which are not advertised today on the internet. So there is a question here. What's the reason for that? On the one hand, that seems good for IPv6. Probably it's good, or better, could be explained as a sign that since IPv6 is used more than before, that has freed up more IPv4 addresses. But looking at the article, Dr. Houston also, let's say, provides another possible explanation, which could be related to an increased use of network address translation. So, if so, clearly there could be an impact on the deployment of IPv6 that could be further delayed. Clearly, more investigations are needed here. Next slide, please. And we are approaching the section named Call for Action. We tried in version 1 of the draft, and we are still trying in this edition of the draft to put comments and considerations with the scope of providing arguments or even actions to support IPv6. Clearly, we could look at this section as a way to try to answer to the question posed by Fred. For sure, more needs to be done. In version 01, we touched briefly at the transition choices for service providers and enterprises, the operational aspects, something related to security. We added, let's say, more text for cloud providers and data centers. We have already mentioned that IPv6 is widely adopted. There is one point, though. Cloud providers are also active in gathering IPv4 addresses, probably to answer to their business needs to provide connectivity for enterprises. So there may be, let's say, an impact one day, the day we will approach a real exhaustion of IPv4 addresses. The use of an IPv4 address for an enterprise will turn into a fee to be paid. Then we have industrial internet. For sure, IPv6 is envisioned as a key foundation for connectivity. Probably there is work to be done to make people more aware of the potentiality of IPv6, mainly in the application development side. And I will move to the next slide, please, where we added some considerations for industrial IoT, which is quite similar to the previous one. So once again, IPv6 could be leveraged for the characteristics to provide automated configuration or configuration-less, let's say, capability. But once again, there are issues to be investigated. And then we have a final section on government and regulators. And in dealing with this topic, we tried to summarize our findings with the motto, stimulate if you can and regulate if you must. Why that? Because we have looked at some countries, mainly the European Union area, where we have some countries where the local authorities, the local regulators did a good job in supporting IPv6. So we have examples in Belgium, France, and Germany, which are quite ahead of the other countries in terms of IPv6 adoption. And a good example, and I'm going to close my presentation here, comes from ARCEP, which is the French national regulator that mandated the obligation for the operators awarded with a 5G license, the obligation to implement, to support IPv6. There are some reasons that ARCEP provided to, let's say, motivate this choice, but basically they pointed out that this is important not only to support future applications, but also to avoid, let's say, any hurdle or barrier to new entrants in the market. So something could be also taken from that, just to elaborate, more actions to answer to the issue of further pushing IPv6. So that if we can move to the next slide, which is the last one of my presentation. Next steps. So for sure, we are open to listen to the community. If there is anything missing, we are available to consider more topics, try to put more considerations in favor of IPv6 for sure. And I'm echoing what Fred suggested at the beginning of the sessions. IPv4 exhaustion could be also debated. I think it's a hot topic that we have to deal with. And I'm pretty sure that more incentives could be added to the draft and more could be also included in the discussions. Clearly, we are open to contributors, and as said, we welcome any comments that could be provided. So this is all. Thank you.
Okay, thank you, Paolo. Let me, do people want to jump in the queue to say something? We have a few minutes left during this session during which we can have a Q&A.
Fred, could you put me in the queue?
Yeah, well, go ahead.
Okay, no hats on. A couple questions. A couple things that would motivate the deployment of IPv6 is an increase in the price of IPv4 addresses and an emergence of a part of the internet that is IPv6 only. Have we seen a steady increase in the price of IPv4 addresses? And do we see any IPv6 only islands of the internet yet?
Well, the answer to both of those questions is yes. If you go to, I think it's IPv4market.com, they are essentially if addresses were real estate, they would be a real estate agent. They connect a buyer and a seller. And they have an interesting graphic in which they look at the price of an IPv4 address, which when that market first started was around $14 or maybe $12 an address, and is now at about $20 an address. And I would suggest that you look at that graphic. We have seen an increase in the price of an IPv4 address. And Geo that spoke to us last month or at the last meeting talked about having a number of different services up, all except one were IPv6 only. So yes, there's at least that one island of IPv6 only capabilities. And I believe Jen might tell you that within her company, at least part of it is IPv6 only. That's been a big project of hers, and she talked about it. So yes, we have some islands of IPv6 only capability.
So I should call my wealth advisor immediately and have him invest in IPv4 addresses. Just kidding.
Okay, any other comments? Failing that, let's move on to the discussion of the RTO dependent flow label generation. Alexander, are you around?
Okay.
Okay, so you're on.
Hang on just a second.
Yeah, sure. Yes, this one.
Okay.
Great. So good evening, everybody. My name is Alexander Azimov. I work for Yandex. And today I'm going to discuss with you flow label as you can see, it's on the slide. It's a relation to the TCP socket hash and what is in the IETF documents and what is really in the Linux kernel. So next slide, please. So if you ask data tracker about flow label, it will give you this kind of response. So these all RFCs that have flow label in its naming. Not all of these RFCs are related to flow label generation, but some of them are related. Some of them even look obsolete. And I'm going to make a quick recap about key statements in these RFCs. Next slide, please. So these two documents discuss application of both stateful and stateless use cases. On the slides, there are a few quotes that I'd like to highlight. The first clearly states that the flow is connected, but not necessarily mapped one-to-one to transport connection. It also states that non-zero flow label should not be changed by middle boxes. And though the field is unprotected, the flow label must not be used alone in the hash function during load balancing. The second part of this document discusses the use of the flow label as a kind of network function, similar for what we really have in MPLS these days, or we will have in Ipv6, MPLS. And let's move to the next slide. This document further discusses the use of flow label as packet classification. This kind of use case brings a lot of complications and technical requirements. It requires to keep flow label state at the routers. It requires special processing of unknown flow labels. Of course, it requires garbage collector. And also from this document, it's of course required that flow label must be fixed for the transport connection. So it's slightly different in statements from the previous one. And what is important that this document is 10 years old. And I believe that with high confidence, we can say that there is no this kind of deployments. So nobody in a real network is using flow label as for packet classification. At least I'm not aware of it. Maybe I'm wrong. Next slide, please. And finally, RFC 6438 tries to put the final dot to the argument about if it's good to use a stateful or stateless flow label. And so it clearly states that flow label should be used in stateless loud distribution. And it highlights that you cannot rely at flow label as end-to-end signal because it may be changed in the path. So stateful uses of flow label are not recommended, at least. And next slide, please. The next document expands the use of flow label in stateless load balancing, mainly focusing IPv6 tunnels such as GRE or IP in IP tunnels. And in current world, it's also, of course, related to Ipv6. And next slide, please. So this is the last RFC that is related to flow label generation. it is a bit out of the line. In this document, it is suggested to use flow label in stateful load balancing, but not at the level of routers, but at the level of normally we call it layer 4 load balancers. It gets the same restrictions for the flow label. So it's again asked to make it fixed for the transport connection. The purpose of this document is it tries to address fragmentation, of course, but in reality, it again relies that flow label is immutable. It is not correct, and it was discussed in previous documents, and these make some questions about this one. And it also creates a gap in the security. It gives a way for fragment flooding. And more than this, as we will discuss further, if anybody have deployed such a system, they should have experienced problems with Linux boxes. For as far as I know, there is no such deployments at the moment. So this is a very short summarize on about what is stated in IETF documents about flow label. Let's take a look about a Linux kernel deployment related to flow label, but not limited to it. Next slide, please. So it was 2014 when the support for flow label generation based on the TCP hash was added in the Linux kernel. It was mainly addressing the RFC 6438, so it's not about flow label only. It's about any kind of encapsulation. And we will get back to this a bit later. Next slide. But next year happens a very important change in the logic of generation TCP hash and respectively flow label. It says that TCP hash is recalculated after negative routing event. What is negative routing event? Normally we are used to know it as a RTO timeout. And so this is very different from what is in the IETF documents. So this makes the TCP hash may be changed during the lifetime of TCP connection. And flow label may also be changed. Next slide, please. The next year, this solution is further strengthened. And now the hash is recalculated upon each SYN RTO or any kind of or just standard RTO timeouts. So if we are losing SYN packet, the hash value is changed. If we have an RTO timeout during lifetime of TCP session, hash is changed, and so respectively flow label is changed. Why it is that important? What is the problem that was these changes were addressing? Next slide, please. Imagine that you have two hosts that are trying to establish TCP connection between each other. And for example, these hosts may be in data center, they may be not. But anyway, so the outage happens on one of the paths that may be used by these hosts. So in this case, let's say that there is an outage on the device S1. And the SYN packet that was sent from T1 to T2 was lost. In this case, according to the Linux kernel, the hash will be changed, and so flow label will be changed. And to redirect the second scene that will be sent from the one host to another path, one need only one thing. We need to enable flow label hashing on the ingress device. In this case, it says T1. This will give you a chance to give Dhcp a fantastic property. So in case of outage on one path, it will jump to another. The more alternative paths you have, the higher is the chance that your services will not be affected by the network outage. Next slide, please. So this is an experiment that was run in a production network of Yandex. We took a top-of-rack switch, which had 4 uplinks. And on one of the uplinks, we created a packet loss. So it was just dropping all the traffic that was going through this link. And you can see on the left side the data from our data plane monitoring. And it just says that we are losing 25% of packets that are destined to these top-of-rack switch. On the right side, you can see the disruption that happens to services inside the switch. And just to mention, it says in a network IPv6 only. Next slide, please. Now we enabled flow label hashing on this top-of-rack switch and reproduced our experiment. On the left side, you can see that the data plane monitoring is just the same because it's not aware of TCP, it just sends packets, and so it still sees 25% of packet loss. But on the right side, there is no effect. So the services inside this rack were not aware that something bad happened to the network. Of course, you need to make some additional configurations. You need to change values of RTO timeouts, but it will not be possible without these changes of flow label during TCP session lifetime. Next slide, please. And as we discussed, it's not only flow label, it's a TCP hash that changes. And there are dependencies for this TCP hash in Linux kernel. So it's flow label, and every other kind of encapsulation. For example, upon RTO, it's the key fields in GRE will be changed. It will change also source port in the UDP encapsulation. And if, for example, you will use any kind of IPv6 encapsulation, it will also affect the flow label of the out header. Next slide. And by the way, it's a Linux default. So the default behavior is to use this kind of flow label generation. So at the moment, we have some Linux kernel developers that enriched TCP over IPv6. It works only on top of IPv6. It's not working for IPv4, of course. Enriched it with self-healing capability. But if it was all that great, I would not have created these slides, and you won't be suffering from my Russian accent. Next slide, please. There is a side effect. The side effect happens if the user changes the flow label. And on the other side, if there is a stateful any cast without a sharing state. For example, if we have a TCP proxy and the user changes flow label from its side, it may result that the following packets will be delivered to another device that will not have TCP state, and it will respond with RST, or it will not respond at all. So the results of this kind of situation will be normally session timeout. Unfortunately, we faced this kind of scenario for our users, and as an ad hoc, we had to switch off flow label balancing at our board routers. Unfortunately, it was helpful only in a subset of cases. So, next slide, please. The good thing that it can be fixed. So, normally we have two sides of TCP session. We have client that sends SYN. We have server that responds with SYN ARC. And this kind of problem can occur only on the side of the client. And so we can keep the behavior of the server as it is now in the Linux kernel. So the server can recalculate its TCP hash and thus change flow label after each RTO. But on the client side, it should be switched by default. There must be a knob to enable it in the controlled environment, because, for example, in data centers where you know where is anycast and where is just a unicast addresses, it's safe to use it, but you should know where to use it properly. Next slide, please. And as you see, this is my last slide, and I'll try to summarize both current staglatization and deployment status. There are multiple RFCs related to flow label generation, though some of them look obsolete. There is non-started behavior in the Linux kernel, and maybe other operation systems I'm not aware about it. That improves TCP connection stability in case of packet loss on one of the paths. As for now, it is deployed at least at 3 hyperscale clouds. Unfortunately, it also introduced a mistake that may result in a TCP session timeout. It can be fixed, and a good thing, according to the discussion in the mailing list, it will be fixed. But I believe it's also important to update related standards to reflect what is happening in the real-world deployments. Otherwise, there will be a growing gap between what is written in 10 years old documents and real implementations. That's all for me. Any questions? I think Fred got disconnected.
Oh, okay. I can't see if there's anyone in the queue. If
I have a question, it's Gian. I don't know if you.
Go ahead, Gian.
So this was a really good overview of flow labels. So, I wanted to mention, I think this is, comparing like IPv4 to IPv6, I think that first bullet that second bullet, flow label actively used for stateless load balancing. I think overall, that's really a real massive gain, like going from V4 to V6. So with V4, because there's no entropy built into the V4 packet, no flow label, you can't do per flow load balancing. It's versus flow-based load balancing. So every flow, each flow is hashed to an individual link. Let's say if you have an ECMP. So the really the huge gain with really, and it's really overall for IPv6 deployments for operators, that if you move towards IPv6, being able to take advantage of that stateless load balancing is a real massive gain. With that, in your testing that you've done, have you tested across different vendor boxes, like I don't know, Cisco, Juniper, Arista, and whatnot, that they all support stateless load balancing? Because that uniform load balancing that you can get with the flow label, it is a massive gain for operators.
So thank you very much for this very positive comment. Yes, we tested flow label balancing on different devices. There were devices that were not working properly. Some of the vendors have already delivered us software updates, and we are waiting for the last software updates from, I cannot name the vendor, in this Q2.
Okay.
Is anyone else in the queue?
Yeah, Michael is.
Yeah, so you said you prefer to disable this feature per default on the client side because you may reach a TCP proxy, a different TCP proxy. So my question is, if you change the flow label of a TCP connection on the server side in the middle of a connection, how can you ensure that you are not reaching a different middle box like a firewall, which sees the packets and has no states from before?
So speaking about the firewalls, they are not normally in any cast. So they are on path. But
I'm not talking about any cast.
If you are heavily relying that all packets of the TCP connection today are coming from one path, your firewall normally will not be working that good as this is possible. So if you have a symmetric path and you place a firewall, for example, near your gateway, single gateway, everything will be perfectly fine. But so from the server side, it's at least safe. From the client side, it may result in a timeout if you are uploading a lot of data through such stateful anycast service. It may be TCP proxy, it may be layer 4 balancer without consistent hashing.
I'm not talking about anycast. I'm talking about a unicast service. Firewalls are on a path, and now one side changes the flow label, resulting in packets taking a different way through the network. So it might not hit the firewall anymore. So a new firewall might be hit and the connection will die.
So may I ask you a question? What happens in this scenario that you have described if the BGP table is changing and the path to the client is changing? Does it result in immediate TCP session interruption? So
I'm talking about a temporary problem which results in a timeout, and you change the routing of the packets.
Yeah. I'm talking about another source of changing path from content provider, for example, and the end user. So if you have multiple firewalls that are expected to be processing the TCP session without traffic redirection, I think it's already broken without any flow label changing. And by the way, flow label is already changing, and so it's not something that I suggest to introduce. It's what's happening now.
Okay, now we've only got a couple of minutes left for this, and then we have one more talk. So Luigi, you wanted to say something?
Yes. First of all, thank you for the presentation. It's very clear and interesting. I wonder with your proposal on safe mode, what happens if the path is asymmetric and the problem is in the, let's say, the uplink from the client to the server. And in that case, you don't have the same performance you showed with this experiment where you have the 75% drop, right? This may happen.
Yeah, you're correct. So,
did you try to do an experiment in that?
Yes, we are currently running a couple of experiments, and from the content provider that I'm working for, normally the biggest issues happening not on the ingress side, but on the egress side where the majority of traffic is going. It's not through the, it's not destined to our network, it goes from our network. And there are the places where, for example, congestion happens and this value of TCP to jump from one path to another path becomes that valuable. But you're right that, for example, if there is a packet loss on the forward path from the client to the service provider, if the safe mode will limit opportunity of the client to jump from one path to another, even if it exists. There is a trade-off. So TCP timeout in some situations or benefits in another. The safe mode, as I see it, is an easy fix. After that, one can think about kind of negotiation between client and server that in which the server will permit client to change its flow label. For example, if the server knows that everything will be fine, okay, just do it. But safe mode is, from my standpoint, is something that should be deployed in first place.
Thank you. I have just another quick question. I hope the answer is also quick, otherwise we take it to the list maybe. What happens in the context of MPTCP? If you have multiple TCP connections, is the same principle that applies? How is the flow label managed?
It's not that easy question. So
okay, let's take it to the list maybe.
Okay.
I think we need to take this one to the list.
Okay, fine.
John, you wanted to get in, and I'll give you the last word, and then we need to move on to Fernando.
All right, thanks. I added just another quick question. You know, because you've had, seems like a lot of erratic results with using state, you know, the stateful marking of the flow label. Is there a feature, I guess, you know, probably from an operator standpoint, maybe it makes sense to, like, you know, like let's say with QoS, you could actually have trust to like trust the flow. Is there a way to like remark the packets on a switch so the flow so you unmark the packet so the flow label is not set? You know, let's say on the a port connected to a host that you can you know, keep it untrusted or just mark it so that it's not used, so that hosts don't actually try to use stateful because of the erratic behavior that you can see with stateful. Thank you.
I'll try to answer this question, though I can't say that I've followed it fully. But we never remark flow label at the top of rack switches or in any part of the network. No part of the network keeps the state of the flow label. It's just in the hash function of ingress devices. The ingress device may be top of rack switch. It may be at the entrance of MPLS cloud. So that's all. And I'm not aware of any other stateful use cases of flow label. There are quality of service, as you said. There is MPLS for other use cases. There is tunneling for other use cases.
Understood. But you know, on the top of rack, like that ingress point, could you actually, just like a QoS packet, like the DSC toss field, can you set it so everything is, so that the field is not marked, so you don't have erratic behavior? Because it does seem like when the host sets, and tries to use a flow label for stateful operation, that it seems like from your testing you have a lot of erratic behavior. But if on that top of rack, if you marked it so that it's not set, so the flow label is not set for stateful signaling, I don't know if that's possible. I mean, I guess it would prevent any erratic behavior, that could possibly happen.
Unfortunately, I can't at the moment imagine the use cases for any kind of stateful flow label that will be really working. But we can move this discussion to the mailing list.
Okay.
And if you see them, please tell me.
Thank you.
Okay, thank you. So I need to move on to Fernando's talk. So Ron, you want to change the slides there?
All right, I can't get this thing to work.
Good. Can you hear me?
Yeah, I can hear you.
Okay. So I'm Fernando Gont, and I will be presenting this document on IPv6 addressing considerations. Next slide, please. So what's the goal of this document? Essentially, this document tries to do three different things. The first one is to perform an architectural analysis of IPv6 addresses, try to figure out what are the the properties that they have and what are the implications of such properties. Then we try to analyze the extent to which IPv6 addressing is currently leveraged. And finally, what we do is try to do a gap analysis, that is, try to find out what things are missing for us to be able to fully leverage IPv6 addressing. Next slide. So when analyzing the address properties, we came up with a few different categories. The first one is that of scope, which is actually formally defined in the IPv6 addressing architecture. Essentially, the scope is the network span where an address uniquely identifies a network interface. Okay. As a consequence of that, you can say that the scope has an implication on reachability. Reachability will always be smaller than the scope of the address. And there are implications of the scope. For example, if you were meaning to offer a service only on the local link, but instead of using link local addresses, you use global addresses, then that service would be exposed to a larger part of the network than necessary. It also has implications on address stability. For example, for the particular case of global addresses, if you have provider-dependent addresses, then your addresses might change over time. For example, if your upstream numbers. Second property that we discuss in the document is that of reachability, which essentially implies more than just the scope, because it also implies, the scope does imply a limit on reachability, but there are other things that affect reachability, such as, for example, filtering policies. And the implications of reachability is, of course, that of host exposure. Okay, an address that is reachable from everywhere, of course, means that node, that host, is also reachable from everywhere. For example, for attack purposes. Next slide. Other categories, provider dependency. This is provider dependency is normally analyzed in the context of global addresses, like PI versus PA space. But in this case, we talk about this property like in a more general way. And essentially, we refer to this property as the extent to which an address is tied to your upstream provider. Upstream provider could be anything, could be another router in your same network, and that router might be leasing you ULA prefixes. Okay, so the idea here is if the address that you're using depends on the upstream, then it's dependent on the provider, and if not, it's not. Implications of this, one of them is address stability, like for example, the work that we have done in V6OPS about the flash renumbering events. So if your address depends on your provider, then if the provider renumbers, then your addresses will change. And for example, in the case of global addresses like PI versus PA space, obviously it has an implication on your ability to do multi-homing. Okay. The final one, if I remember correctly, is that of stability, which, as the name implies, has to do with the extent to which an address changes over time. The address changes are associated with at least two different things. One is the prefix stability. That means that if your upstream renumbers, then you may have to change your addresses, whether you want it or not. And then, the stability is also related with the address type. Like, for example, in two of the cases, you have stable addresses that are, as the name implies, expected to remain stable in the network. And you also have temporary addresses, which by definition, of course, they change over time. Stability of addresses have implications on a large number of areas. One is host exposure. The more you use an address, the more that host will be exposed via that address. It also has implications on privacy, because of course, the more you use an address, the longer you will allow for network activity correlation based on the address itself. Of course, there are many ways in which you can correlate activity. And finally, it also has implications on operations. Why? Because, for example, there are devices that might not be able to cope with systems employing many addresses, or with changing addresses all the time. All the times in some enterprise deployments, they might expect the addresses to be stable, for correlation or logging purposes, for ACLs too. There were also comments on the V6OPS mailing list regarding ACLs that you might even want to, enforce on your CPU router. Since if your home network is employing global address space, it might be difficult for you to configure ACLs on your CPE, because if your ISP renumbers you, then the ACLs should change accordingly. So there are a number of implications associated with stability. Next slide. Okay, so how are addresses currently being employed? Well, when it comes to configuration, it's normally one size fits all. Like, for example, I use Ubuntu on my laptop, and I get the same kind of addresses no matter where I connect to. For example, Ubuntu will, if addresses are being provided with Slack and the Dhcp, it will configure addresses with both. And when it comes to Slack, it will configure both stable and temporary addresses. And it doesn't matter what kind of network I connect to. I always get Ubuntu has at least as far as I know, the same policy for configuring addresses. Where you might want to do something different. Okay, for example, if you were to connect to your home network, you might want to do both stable and temporary addresses. But if, for example, you have a mobile device, you might want to use just temporary addresses. Okay. When it comes to usage, it's the same thing. So the approach that is normally employed is one size fits all. So when it comes to clients, normally, hosts employ the, IPv6 default address selection, meaning that, you pick your source and destination addresses based on that RFC. And when it comes to, servers or server-like operations, the normal behavior is that you accept incoming connections on all of the configured addresses, okay? which is at the very at least suboptimal, because that means that, for example, addresses that you expose to the outside world by doing client-like communications could also be leveraged or used to actually access services that you might be providing in your local node. There is like a famous case of host systems that they were exposing their IPv6 addresses when using NTP to synchronize the time, and then right after doing NTP, they got port scan by using the temporary address that had been employed with NTP. Next slide. So implications, some of them I discussed already. When it comes to address configuration, I would say that one size probably doesn't really fit all. At times, the host expectations are different from the network expectations. For example, a host might want to configure many addresses, which is actually a BCP right now. But the network might not be willing to do that, or maybe the network might be willing to allow for some number of addresses, per host, but it's impossible for the host to know what that number is. What's like a number of addresses that is acceptable to the network. So you have a case of different expectations from the host side and from the network side. There is also the issue of Slack and the DHCP interaction. For example, that's the case of my own box. I have an Ubuntu box that does 7217 and 4941 for configuring the Slack addresses. That is, it configures Slack addresses in a way that you take care of security and privacy. But Ubuntu, by default, if addresses are also offered on the DHCP, it will configure addresses with the DHCP too. And I happen to have a CPE router that leases IPv6 addresses using a predictable algorithm. So my Slack addresses are unpredictable, but my DHCP addresses are pretty predictable. And of course, the outcome of that is at best suboptimal. When it comes to address usage, there are also implications. For example, an application that expects to have a long-lived session might use temporary addresses, which, as a result of that, results in the sessions being torn down. Think, for example, about the case where you want to have a long-lived SSH session, but SSH employs temporary addresses, and as a result of that, they get the session gets closed, torn down every time. You could also end up using, for example, global addresses for what's meant to be a service that is only provided on the local link. Could be the case, for example, for multicast DNS, if you wish. And there's also the case that it's what happens nowadays, that you may be accepting incoming connections on all addresses, including temporary addresses, meaning that just by exposing your temporary addresses means that you might also be exposing services that might even be meant only for the local network. Next slide. So let's go briefly through some of the gaps that we have. One is the APIs. Essentially, for the most part, we keep using the same kind of APIs that do not really allow applications to essentially signal what kind of properties they expect on the underlying IPv6 addresses. So, for example, for a client application, the application might want to signal that it wants a temporary address, or, for example, that it wants the operating system to configure a new address just to use by that application. So there's a lot of properties that an application, or abstract properties that an application could specify: scope, stability, and so on. There's probably also room for advice on IPv6 address usage, meaning that even if we have those APIs, then we should provide advice to applications developers, for them to be aware about both the API and what's supposed to be the the best way of leveraging IPv6 addresses. Next slide. Other gaps. Well, this is related to to the configuration issue that I mentioned before. It would be great, for example, to have profile-based address configuration, meaning that if you select that if you tell your system that a specific network is, say, a trusted network, you configure addresses of some sort. Whereas in other cases, you do a different thing, like home network. Okay, for the home network, configure stable and privacy. But if I'm roaming, if I connect to an internet cafe, for example, then use only temporary addresses there. So that means that we would switch from one size fits all to specific different profiles. Also, have improvements on how to deal with many addresses. This is kind of like, the result of conversations that we have had in Sixman. For example, allow the network to convey information about, their expectations of addresses so that, the hosts and the, network can cooperate in a better way. Whereas nowadays, the host may configure many addresses, but it might hit a point where, the network isn't happy about that. There have been proposals. This is obviously work not for V6OPS, like, do work to be able to register and deregister addresses, because, so far, devices that may be on the local network, they have no way of knowing, if an address is still in use or not. And last item, have support for prefix delegation, which in some cases we don't currently have. That might be increased support for Dhcp prefix delegation, not necessarily the whole Dhcp version 6 thing, but the specific part of prefix delegation, or having something developed on the Slack side. Next slide. And I think once we're done with it, we can switch to the discussion. Finally, there's other stuff. One is support for firewall traversal in CPEs. Essentially, when you look, that you have many CPEs that enforce a policy of only allowing outgoing communications. That's kind of like mimicking what we have in IPv4 as a side effect, but they don't have support for things like, let's say, IPv6-based universal plug and play or PCP. That means that in many cases, you might end up having IPv6 network where your local nodes employ global addresses, but that filtering policy of only allowing outgoing connections essentially prevents you from offering services with DHCP, which is kind of like ironic. And last item is support for multi-prefix, multi-router networks. To put it bluntly, we do, from my perspective, we do need mandatory support for RFC 8028. For me, it's virtually impossible for a network to support a setup where you have multiple routers and multiple prefixes. The requirement for RFC 8028 right now is a should, but from my perspective, it's like should be a must, like definitely a must. And we also need, of course, increased support of it, because the vast majority of IPv6 implementations do not really support 8028. Next slide. So I guess it's time for some discussion and feedback.
Okay, Jen, you're first in the queue, and you want to comment?
Hi, Fernanda. Thanks. Very interesting document. However, I have a few comments. First of all, I'm surprised that you're saying that your laptop is always configured the same way. I might be wrong, but I think Network Manager does allow you to have different profiles for different, for example, SSIDs. You can have only stable address in one Wi-Fi network and private extensions on another, and so on. So I think that functionality is actually already here. So, and I think the document actually covers a lot of different things, because I agree we definitely need an API so application could get better visibility to property of address, like temporary versus stable and so on. However, I'm a bit concerned that some other properties are not really property of an address. It's a property of the network topology in this particular moment of time, right? For example, the particular network block we are using now might be provided by ISP, but as a result of some paperwork done, it might become a property of the network, so it's not pay anymore. So I'm not sure what you're suggesting here is how can we get that those properties communicated in programmatical way.
Well, one of the options, but that's just scratching the surface. And to be honest, I don't know the extent to which that is, implemented. At the time, temporary addresses, were specified. There's actually an RFC. I don't remember the status of that RFC, but to have, for example, a socket option that allows an application to select if you want temporary addresses. So one of the possible ways in which that could be exposed, I'm not saying that that's the best way, I'm saying that something like that has been proposed, could be via, for example, socket options. I guess something like this could be fed to the TAPS working group, but that's me just thinking out loud. As a comment, sorry, I remember I once, like maybe a couple of years ago, I discussed this a little bit in TAPS, and essentially, and it made sense. Like the folks at TAPS said, we'd like to do something, on the topic. That's what I remember at least. But they say, well, we don't necessarily, have the skill set and the knowledge about, the IPv6 specifics. So that means that, for example, it could be, let's say, TAPS that, does the protocol stuff to actually, leverage the addresses, but it might need to be some more IPv6 related working group, the group that, can, essentially feed the IPv6 specific parts.
Well, okay. Are you suggesting there that we change the TAPS charter, that we change the TAPS people that are contributing to it, that we file a bunch of drafts with TAPS and get them to build the expertise by dint of being overloaded? How would you approach that?
So from my perspective, I would think that, well, first of all, agree on the problem. And I would say that, once we agree on the problem, one possibility is to have a separate document in, Ipv6 that talks about the properties that, about the IPv6 address properties and, how we think they should be exposed to, for example, applications, or, no matter where the home is, whether that's Ipv6 ops or TAPS, essentially, if we agree on the problem, we could discuss with the TAPS people, of what is the best way in which they could eventually, act on that. Whether they need something on Ipv6 ops, from where they could take and, do the protocol-related development that might be needed. For example, all the discussion about the properties, what properties might make sense to be exposed to the application and so on, that should certainly come from, IPv6 groups. Because when I discuss that with the TAPS people, they say, well, that sounds interesting, but we don't necessarily have the skill set, and we don't necessarily, know the IPv6 details, so we could not really do the whole thing.
Well, okay, so Ron and I can talk with the TAPS chairs and copy you on it and explore how to go about that. I guess I don't want to import TAPS into V6 ops. TAPS belongs in TAPS. So we need to figure out the best way we can help them do what we want them to do. Something that might be important to them, though, would be a set of requirements. If I was trying to figure out that interface, I would want something from the application that says, gee, I really wish I could tell you that I wanted a temporary address or whatever. And that's not something that I would expect V6 ops to produce, but something from the application area, frankly, or transport.
Yeah, one thing that, the one problem with that is that the people that might benefit from that, they don't necessarily have the detailed knowledge about the properties that we have. So it's the guys that would use it, maybe they are they are not really aware about the details. That's why I think there some sort of coordination between the V6 people and the application people might be necessary here, right? I don't know the exact way of doing that. And for sure, I think that this document is a problem statement, but for each of the things and each of the gaps that are discussed, there should certainly be at the very least some spin-off document that focuses on that, on coming up with a a more detailed problem statement or a solution.
Well, that may be. Once again, that would be something that I would think that that Ron and I could talk, including you, with the TAPS chairs and try to figure out where those requirements would come from. Now, I don't want to. We're actually 5 minutes over time, and we've still got Luigi and Bob in the queue. So let me turn this to them. Luigi, what did you have to say?
No, it's just to thank for the presentation. Is a nice document. I join what you said about the requirements that should be written down. I just wanted to say to Fernando that we have something related in the inter-area, which is a challenging scenario on internet addressing. We take a more general perspective. It's not IPv6 centered, but maybe we can talk more offline on this, because I think the two documents are related. So pretty short. Thank you very much.
Okay, thank you. Bob, did you want to say something?
Yeah, I'll be quick. Yeah, I think there may be some things in here that are worth pursuing, but I'm not comfortable with the sort of large document that covers a whole bunch of stuff. And as Jen said, it seems to be a little confused about like what the properties of an address is, because just because you get renumbered, the address is still quite stable. You just don't get to use it anymore. So I think, I think pulling this out for some specific problem, like we were just talking, would make sense. But I'm not very comfortable with sort of the umbrella document that's trying to cover lots of topics separately. Thank you.
Okay. So thanks for that. Before we go, let me ask a question. For the last several meetings, Ron and I have basically taken a week and asked the working group to talk about a particular document each week. Have people found that to be useful? Let's see here. I guess I should actually make this a hand raise kind of a thing. Okay, show of hands tool. So, okay, I have just put a question out, and you guys can either raise your hand to say yes, or don't raise your hand to say no. So if you're finding those sessions to be useful to kind of coordinate on, fine, let's talk about this document, then I want to continue with that. If it's not useful to you, then it's something I shouldn't be doing, or Ron and I shouldn't be doing. So, okay, out of 47 participants at this point, I've got 11 that said, yes, it's useful to me, and I guess the rest of them that didn't really find it useful. 12. Okay, tell you what, we're going to take these 4, I guess, documents and have that discussion. And if people find it useful, they can comment on it, and we'll see where that goes. But so a meta question is, do you want to do that? And with that, we're at this point 9 minutes overtime, and I tend to think we should probably close the meeting. So consider this meeting adjourned.
Take care, everybody.
Bye.
Bye.